Hi everyone. In this video, I'm going to review the problems that you should practice and study for the test on chapter 11 and 12. So in number one, we're looking for the greatest common factor. So the first thing I need to do is look at my terms, and I notice there's a negative. So I'm going to pull out a negative for my greatest common factor. And then we want to find the greatest number in common that divides into 45, 15, and 5. And the highest number that goes into all three of them would be 5. And all of the terms have an x, and I want to pull out the variable with the lowest exponent because, again, I'm looking for the greatest common. So if you think about it, this would have 6x's, this would have 7x's, and this would have 8x's. The most I can take out of each group would be 6, right? I can't take out 8 because there's only 6x's here, but I can take 6 out of each of these. So you take the variable with the lowest exponent. So my greatest common factor would be negative 5x. Here's another problem where we are factoring out the greatest common factor from the polynomial. So my greatest common factor here, I'm going to look at my terms, and my terms have a 6 and a 3. So the greatest number that goes into both is 3. And they both have a y. Again, I'm going to take out the variable with the lowest exponent, which would be the third. So my factor would be 3y to the third. Okay, so now it says factor out the greatest common factor. So what we would have left over is I'm going to divide each of the terms by the greatest common factor. So when I do that, 6 divided by 3 gives me 2, and y to the 7th divided by y to the 3rd gives me y to the 4th. I'm subtracting the exponents, 7 minus 3, anytime you divide like bases. And then I've got plus 3 divided by 3, and y to the 3rd divided by y to the 3rd. So whenever you divide the same thing, you always get 1. So I would put a plus 1 here. And if you want to check this, you can distribute. 3y to the 3rd times 2y to the 4th gives you 6y to the 7th, and 3y to the 3rd times 1 gives you 3y to the 3rd. In number 3, I'm factoring out the greatest common factor again. So if you break this problem down, if you notice, both pieces have an x minus 5. And if I factor out an x minus 5 out of the first two terms, I'm going to just be left with y. And if I factor the x minus 5 out of here, I would be left with the minus 9. Here we're factoring the 4-term polynomial by using a method called grouping. Grouping is typically used when you have 4 terms in a polynomial. So I'm going to first try finding the greatest common factor for the first 2 terms, and then the greatest common factor for the next 2. So if I look at the first 2 terms, I notice 2 is the greatest common factor of 2 and 18, and they both have an x. So you have to choose between factoring out an x squared or an x to the first. Remember that the greatest common factor of the variables would be the common variable with the lowest exponent. So that would be x to the first. So my greatest common factor for those 2 terms would be 2x. And if I divide 2x squared divided by x, I get x, or 2x rather. And then if I divide negative 18xy by 2x, I get negative 9y. And I should end up with the same common factor in the next terms. So if you notice here, you have a negative 7 and a 63. So I can factor out a negative 7. And negative 7x divided by negative 7 leaves me with positive x. And 63y divided by negative 7 is negative 9y. And if you notice, you have the same terms here, the same expressions, just like we did here. So I'm going to factor out an x minus 9y, and the leftovers would be the 2x and the negative 7, and they just go in the other parenthesis. In number 5, I have a trinomial, and again, your first step is to always factor out a greatest common factor, and there is no greatest common factor for these three terms. So to factor this one, I want to find two numbers that multiply to give me 16 and add to give me -10. And my rule for the signs is I'm going to write down the first sign I see, which would be a negative, and then I'm going to multiply the signs together. A negative times a positive gives me a negative. So two negative numbers that multiply to give you 16 but add to give you -10. If you want to pause the video and try thinking of those numbers, that would be great. Gives you good practice, and then you can unpause it when you're ready. And those would be -8 and -2. -8 times -2 is +16, and so they multiply to give us +16. When you add -8 and -2, you get -10. So now to factor that, I'm just going to have an x in each parenthesis, because x times x is x squared, and then you're going to have a -8 and a -2. To check it, you can FOIL, which remember stands for first, outer, inner, last. So if you multiply x times x, you get x squared. And x times -2 gives you -2x. And -8 times x gives us -8x. And if I add them, I should get the middle term, which I do. It's -10x. And then -8 times -2 gives me my last term, which is 16. So that's how you can check to make sure your answer is correct. So your final answer is x minus 8 times x minus 2. We're doing the same thing with number 6. So you're factoring again. And I'm going to let you all try that on your own. The answers are at the end of this document, so you can check. In number 7, we're trying to find two numbers that multiply to give us 2 and add to give us 5. And when you try to think of two numbers that multiply to give you a +2, the only two numbers are 1 and 2. If I try to add 1 and 2, it does not give me 5. So this polynomial is known as prime. It's not factorable. In number 8, again, first thing I want to do is look for a greatest common factor. And there is one. 3 goes into 3, 12, and 9. So the first thing I'm going to do is factor out a 3. And to get the leftovers, you're just dividing. 3 divided by 3 is x squared. 12 divided by 3 is 4x. And 9 divided by 3 is 3. So now you're going to try to factor this. So we want to look for two numbers that multiply to give us 3, but add to give us 4. And my signs are going to be a positive. Positive times positive is also positive. So I'm going to have two positive numbers. And you can pause the video. Think of the numbers that multiply to give you 3, that add to give you 4. And that would be 1 and 3. So now this 3 just drops down. And this will factor into x plus 1 times x plus 3. And then this is your final answer. In number 9, we're going to do the same thing. We're going to complete the factored form. So they're giving us one of the factors. It's 2x plus 3. We need to find the other one. Okay, so what you're going to do, since there's an a term, here's a, b, and c, I'm going to multiply the 20 times the -3, which would give me -60. And you're looking for two numbers now that multiply to give you -60, and they have to add to give you 28. And I'm going to, again, for my signs, I have a positive, and then a positive times a negative is a negative. So I'm going to have a positive and negative number. They have to multiply to give you -60, and they have to add to give you a 28. So that would be 30 times -2. So I'm going to have x plus 30 times x minus 2. remember the a value that kind of disappeared when we multiplied the 20 times the -3 to get the -60? We're going to go ahead and divide those numbers by the a value. And we'll reduce it first. So 30 divided by 20 reduces to 3 over 2. And 2 over 20 reduces to 1/10, because 2 divided by 2 is 1, 20 divided by 2 is 10. If they don't divide evenly, the numbers on the bottom just go to the top. So this would be 2x plus 3, which is this factor here, and the missing factor then would be 10x minus 1. In number 10, we're going to do the same thing. We're going to first look for a greatest common factor, and there is not one. So we're going to multiply our a and our c values together. And 2 times -5 is -10. My signs are going to be a negative and a positive, and I get that because the first sign I see is negative, and a negative times a negative is a positive. Pause the video and try to think of two numbers that multiply to give you -10 that add up to -9. And that would be -10 times 1. So now you're going to have x minus 10, x plus 1. Remember the a value that disappeared for a second. We're going to divide those numbers by the a value and reduce. 10 divided by 2 is 5. 1 can't be divided by 2 evenly, so we're just going to carry the 2 up, and it's going to be 2x plus 1. And then this would be your final answer. Please feel free to also use factoring by grouping, as that was another technique that you could use back in chapter 11. So that is an option as well. Okay, I'm going to leave number 11 for you all to try. Again, the answers are at the bottom of the document, so you can check your answers. I am going to show you how to do number 12, since number 12 has both an x squared and a y squared. So the only thing that's going to change is when you factor it, not only are you going to have an x, but you're going to have a y in the problem as well. Okay, so again, look for a common factor, and there's not one. So I'm going to multiply 9 times 13, and that gives me, let's see, 7, carry the 2, 117. So I want two numbers, and they have to multiply to give us 117, and then add to give us -42. And my signs are going to be a negative and a negative. Okay, so now we're going to try. So 117, right? We're going to start with the number 3 and see if 117 divided by 3 gives us a number that will give us 42 when we subtract. So let's see. 117 divided by 3 gives us 39, and we can get a 42 from a 3 and 39. So 3 times 39 are the factors that I'm going to use for this. -3 times -9 gives us positive 117, and -3 plus -39 does add to -42. So now I'm going to place these inside here. And then do you remember what the last step is? You're going to have to divide by the a value that went hidden for a little bit. So we're going to divide by 9 and reduce. 3/9 reduces to 1/3. So what I have right now is something like this. And 39 divided by 9, I know 3 goes into 9 3 times. 3 goes into 39 13 times. So you're going to have this. And we can't divide 1 by 3 evenly, so the 3 goes from the bottom up. And we can't divide 13 by 3 evenly, so the 3 also goes up. So it's going to be 3y minus 1 times 13, minus 1y. And then 3y minus 3x. Hold on. It's going to be 3x minus 1y. and then it's going to be 3x minus 13y. Okay. Number 13. So 13 is called a perfect square trinomial. You can also use the method we just used. So the way I know this is a perfect square trinomial is it's a trinomial. It's got three terms. There's two perfect squares. 4, you can take the square root of it, and 1, you can take the square root of it. And then to get the middle term, you take the square root of 4, which is 2, the square root of 1, which is 1, and then you double your answer, which just means multiply by 2. This should give us the middle term. 2 times 1 times 2 is 4. When it's a perfect square trinomial, when it works out like that, it's going to factor into something really easy. It's going to be so what's going to happen is it's going to be 2 parentheses, but you can really write it as 1 expression squared. So what you do is you take the square root of 4a squared, the square root of 4 is 2, and the square root of a squared is a, and then you take the square root of 1, which is 1, and whatever the sign in the middle is, so you write down the first sign you see, and then you multiply the signs together. A negative times a positive is a negative. If you notice, both of those expressions are the same, so we can just write it as 2a minus 1 squared. So that only works when we have what's called a perfect square trinomial. So you have to have 2 perfect squares. It's got to be a trinomial. And to get the middle term, you double the product of the 2 square roots. Number 14, we have a polynomial with 2 terms. That's called a binomial. And we actually have what's called a difference of 2 squares. So I know this because I have 2 perfect squares, which are numbers I can take the square root of. And I also have opposite signs. This is a positive, that's a negative. So when you have a difference of 2 squares, it's going to factor into a positive and a negative. The square root of 9x squared is 3x, and the square root of 64 is 8. So your factors are just going to be 3x plus 8 times 3x minus 8. Okay, beware, number 15, we have 2 perfect squares, so you might think this is a difference of 2 squares, but there's a plus right here. There is no such thing as a sum of 2 squares, so you cannot factor this. It is prime. In number 16, we're trying to solve an equation, and remember, when you multiply x times x, you get x squared. This is known as a quadratic equation because you're going to have an x squared term, which would be the highest exponent there. So we're going to apply the zero product property. Since this is already in factored form for us, we know x is a factor and x plus 1 is a factor. So all we're going to do is take each of our factors and set them equal to 0. So one of my factors is x, the other is x plus 1. I'm just going to set them equal to 0 and solve them if you need to. So we can't solve x equals 0. That's already solved for us. But x plus 1, to solve for x, we're just going to subtract 1, and you get negative 1. So your two answers are 0 and negative 1. Those are the solutions. So if you were to plug 0 into this expression, 0 times anything is 0. If you were to plug negative 1 into this expression, you would get negative 1 times negative 1 plus 1. Negative 1 plus 1 is 0, and anything times 0 is 0. So those are both the solution to the equation. In number 17, again, it's already solved for us. It's factored. So you're just going to set both of the factors and set them equal to 0 and solve them. So I'll let you all do that. And you're getting two different answers. Again, the answers are at the end of the document, so you can check those. In number 18, again, we have to solve the equation, but notice this time it's not factored. I know it's a quadratic equation because it's got an x, the highest exponent is a square or a 2. So what I need to do is make sure it's set equal to 0 first. As you noticed, all of these are set equal to 0 when I'm trying to solve a quadratic equation. So to do that, I'm just going to take the 24 and subtract it and move it to the other side. So I would be left with x squared minus 5x minus 24 equals 0. Okay, remember we can't combine these because they're not like terms. This is missing an x. So you remember how to factor this? You're going to look for two numbers that multiply to give you a negative 24, but when you add them, it should give you a negative 5. And my signs are going to be a negative and a positive. And if you don't know how I got that, you can go back. I would suggest you go back to the earlier part of the video and follow along with how I'm getting my signs. So two numbers that multiply to give you negative 24 that add to negative 5 are negative 8 and positive 3. So this is going to factor into x minus 8 times x plus 3. And I'm just going to bring the equal 0 down. Okay, now this is just like the problem here and the problem here. It's factored, so we're going to take each factor and set it equal to 0. We're applying what's called the zero product property or zero product rule. So I'm going to have x minus 8 equals 0 and x plus 3 equals 0. And if you do some quick math here, you would just add 8 to both sides. And here you would subtract 3. So your two solutions are negative 3 and 8. And you might be wondering why I'm putting it inside the braces. That's how we write our solution sets. We write our answers inside a set, which is in mathematics is just a collection of items or elements. So those are the two solutions. If I was to plug in negative 3 into this equation, it would equal 24. And if I plugged 8 into the equation, it would also equal 24. Number 29, we have the same thing, except if you notice, it's a binomial and they're two perfect squares. So how would I factor this? If you guessed a difference of two squares, you would be correct. So remember, a difference of two squares factors into a positive and a negative. And you just take the square roots. Square root of 25x squared is 5x. And the square root of 9 is 3. And then remember, we just carry that equal 0, set each factor equal to 0, and solve. So here I would subtract 3. And 0 minus 3 is negative 3. And then I would divide by 5. So x equals negative 3/5. And my other answer is just going to be positive 3/5. So you would add 3 and then divide by 5. So your two answers are negative 3/5 and positive 3/5. You're going to do the same thing with number 20, except you're going to have to use either the Columbia method or grouping, but you're going to factor that and then set your factors equal to 0 and solve. For number 21, we need to find the value of the expression with z equals negative 3. Remember, we call this evaluating. Evaluating means just replace the variable with the number that they give you. So here it tells me z is negative 3. So everywhere there's a z, I'm going to plug in a negative 3. So I'm going to have 2 times negative 3 minus 5, and then negative 3 minus 8. Notice anytime I substitute, I put it in parentheses. Okay, I need to use my order of operations, which remember again is parentheses, exponents, multiply, divide, add, and subtract. So I need to multiply first before I subtract. 2 times negative 3 is negative 6, and I'm just going to bring the negative 5 next to it. And then I have the negative 3 minus 8 in the denominator. So remember, whenever you subtract, you change the sign, change the sign. Change the sign, change the sign. So I have negative 6 plus negative 5, which is negative 11, and negative 3 plus negative 8, which is negative 11. And what happens when you divide a negative 11 by a negative 11? you would get 1. So 1 is your simplified answer. In number 22, we're asked to find any real numbers for which the rational expression is undefined. Remember, the term undefined is when you have a fraction and you have a numerator divided by 0. Okay, anytime the denominator is 0, it's undefined. So to find where the rational expression is undefined, I'm just going to take my denominator, which is x plus 5, and set it equal to 0. And then I'm going to subtract 5, and 0 minus 5 is negative 5. So the rational expression would be undefined when x equals negative 5. If I replace this x with a negative 5, up here it's fine. Negative 5 plus 2 gives me negative 3. But in the denominator, I would get negative 5 plus 5, which is 0. And anything divided by 0 is undefined. Remember, an easy way to remember it is it's okay to have 0 in the top, just equals 0. No zeros in the bottom. It's undefined. That's very important to remember, especially when you're moving into, intermediate algebra, college algebra. Those are things that you want to remember. Now in number 23, if you notice, the denominator is a number. It's not a variable. That 3 is never going to change. So we don't have to worry about any values that would make the expression undefined. So our answer here is B. In number 24, we're asked to simplify the expression. So just like when I simplify a fraction, I want to break it down and then cancel out any of the common factors. So when I have a rational expression, which is a polynomial divided by a polynomial, I want to factor anything I can. And the numerator h minus 1 can't be factored, but the denominator is a difference of 2 squares. It's going to factor into h plus 1 times h minus 1. And again, the way I know that is it's got 2 perfect squares. 1h squared is a perfect square. You can take the square root of 1 and h squared, leaves you with 1h. And 1's a perfect square. The square root of 1 is 1. And my difference of 2 squares will always have opposite signs. One will be a positive and one will be a negative. And now I need to look at the fraction and determine if there's any common factors or expressions, and there is. I have an h minus 1 and an h minus 1. If you divide both of those expressions, h minus 1 divided by h minus 1, it would give us 1. They're just going to cancel out. So in the numerator, all I have left is 1, and in the denominator, I have an h plus 1. So this would simplify to 1 over h plus 1. In number 25, again, simplifying, I'm going to factor the numerator. So I can factor out an 8. That would be my greatest common factor. And 8x divided by 8 gives me x. 64 divided by 8 gives me 8. And in the denominator, I can factor out an x. Both terms have an x, and you take out the lowest one. X squared divided by x is x, and 8x divided by x is 8. So again, I've got 2 expressions that are exactly the same. They're going to simplify to 1, and you would just be left with 8 divided by x. In number 26, I need to multiply. So to do that, the first thing I'm going to do is factor. X squared minus 81 is a difference of 2 squares. Feel free to pause the video and try factoring it. The square root of x squared is x. The square root of 81 is 9. And I'm going to have a plus and a minus. My denominator, again, is going to factor. I'm going to have a negative and a positive. You need 2 numbers that multiply to give you negative 63 that add to negative 2, and that would be a negative 9 and a 7. And then I can't do anything with x plus 7 or x, so now I just go through and cancel my like terms. So I'm going to cross cancel and cross those out because they're the same. They would equal 1 if you divided them. And then I'm going to cross out the x minus 9s as well. So what I would be left with on the top is x plus 9. And in the denominator, I would be left with just an x. So my final answer is x plus 9 divided by x. Okay, and I will caution all of you, please make sure you don't cancel the x's. Anytime they're separated by a plus or a minus, you cannot cross those out. So please be careful with that. In number 27, it asks us to find the quotient, which just means divide. Remember, when you divide, you skip, flip, and multiply. Or you can think of it as copy, change, flip. So we're going to have to factor the numerator. And then we're going to flip or find the reciprocal of this fraction. So the x minus 4 will be in the numerator now. And then you're going to factor x squared minus x minus 6. And then now I'm going to cross cancel any of my like factors. So in the numerator, I'm left with x plus 7. And in the denominator, I'm left with x minus 3. Now we get into subtraction and addition, and the one thing you want to make sure is that the denominators are the same. With multiplying and dividing, they don't have to be. With adding and subtracting, you have to have the same denominator. And in this case, I do. They're both m minus 8s. So I'm just going to do the operation the fractions tell me. It says take 9m and subtract 72. And now we can place them over one denominator. We're also asked to simplify if possible. So in the numerator, I can factor a 9 out. It's my greatest common factor. And 9m divided by 9 is just m. Negative 72 divided by 9 is negative 8. And in the denominator, I also have an m minus 8. The m minus 8s will cancel, and all you're left with is 9 for your final answer. In number 29, if you notice, I'm subtracting two fractions again, two rational expressions, but this time the denominators aren't the same. So I need to find what's called the least common denominator. X squared minus 81 will factor into x minus 9 times x plus 9. If I look at my denominators, we want one of everything. Both of them have an x plus 9, so that needs to be part of my least common denominator. But then we don't want to forget the x minus 9 as well. Now what we're going to do is very similar to when we were adding and subtracting fractions that didn't have the same denominators back earlier in the semester. We're going to take our rational expressions, we're going to multiply them by the factor that they're missing. So this first fraction, it has an x plus 9, which is part of the least common denominator. It's missing an x minus 9. So I'm going to multiply the top and the bottom by x minus 9. And then my other denominator, if I rewrite it in factored form, you'll see that the denominator contains both pieces of the LCD, so I don't need to multiply that by anything. Now what I'm going to do, I scan my denominators. I have the same exact denominators. So I'm just going to simplify the numerators. I'm going to have 10 parentheses x minus 9, and then I have minus 9x. And that's all going to go over my least common denominator. And then I'm going to simplify. So I would need to distribute 10 times x and 10 times negative 9. And in the numerator, I can simplify. I would have 10x minus 9x, which is 1x, minus 90, and then over x plus 9 times x minus 9. And that would be my final answer. In number 30, again, you're trying to add a fraction and a whole number, and they don't have the same denominator. So I'm going to find the least common denominator. The denominator here is a 1. So my least common denominator has to be just the letter m. So I'm going to take each fraction and multiply it by what it doesn't have. This already has an m, so I don't need to worry about it. But 6 over 1 does not have an m. Now I have the same denominators because I have an m, and 1 times m is m. So now you just have 5 plus 6m divided by m. And that would be it. So I hope you all learned a lot from the review. Please take the time to practice these problems, especially the ones that you might be weak on. Do them several times until you feel comfortable with them. The more you practice, the better you'll do on the test, and you'll feel more comfortable solving these problems, because if you're taking intermediate algebra, this is something that you'll see again in more depth. Enjoy the rest of your day, everyone. Thanks for watching. And if you have any questions, please feel free to reach out to me.